Welcome all of you. Myself, Dr. Dinesh Gupta, Department of Chemistry, School of Sciences, UP Rashtriya Tandon, welcomes you. Here, we introduce you course code 101, Inorganic Chemistry 1, Basic Inorganic Chemistry, Unit 4, Journal Studies of S Block Elements, Module 1. In this unit, Journal Studies of S Block Elements. This unit divided into 3 modules. In first module, in this lecture, we study Introduction, S Block Elements, Comparative Study and Diagonal Relationships, Silent Feature of S Block Elements, Hydrides, Solvation, Complexation Tendencies, and their functions in biosystems, and introduction to alkyl and aryls. And after this lecture, you will see in module 2, you will study chemical reactivity of alkali and earth alkali metals, use of S block elements and their compounds, lithium, sodium and potassium only, organometallic compound of lithium, sodium, potassium, beryllium and magnesium. In module 4, you study polyether complexes like crown ether complexes of alkaline metals, extraction and isolation of lithium, beryllium and radium from their minerals, summary, terminal questions and answers. First, we see the electronic structure of group 1. It's called alkaline metals. In group 1, we find hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. And this is the electronic structure or electronic configuration of the metal. And the valence shell have S1 electron in their valence cell. And another group is group 2, alkaline earth metals. Here we learn beryllium, magnesium, calcium, strontium, barium and radium. And their electronic configuration, in the valence electron we have two S2 electrons. S2 electrons in their valence shell. Group 1 atoms are largest in their horizontal period in the periodic table. When electron is removed to give a positive ion and the size decreases considerably. However, because of difficulty of reducing the alkaline metal ions, the element were not isolated easily till date. Two of the alkaline metals, sodium and potassium, are essential for human life. Their careful regulation often important in treating a variety of medical conditions. Alkaline metals are silvery except for cesium, which has golden appearance. All highly reactive solid having low melting points. They are ordinarily stored under non-reactive oils to prevent air oxidation, they are soft enough to be easily cut with a knife. Their melting points decreases with increasing atomic number because metallic bonding between atoms become weaker with increased atomic size. Physical properties of alkaline metals. What are the physical properties? Here the properties: atomic number, molar mass, density, atomic radius, ionic radius, melting point, boiling point. Here atomic number, you see in their configuration they have S1 configuration at their last orbit. Atomic radius, here you see atomic radius increases gradually. Melting point and boiling point, melting point also decreases gradually. Ionic size also increases gradually. Ionization energy decreases gradually. Electronegativity decreases gradually. And flame coloration, crimson red, golden yellow, violet, violet and violet. Here the physical properties of alkaline earth metals, where electronic configuration of last orbit is S2. This is the atomic number, this is the molar mass, density, atomic radius. See, radius increases and ionic radius also increases. Melting point decreases and boiling point also somehow decreases from the above to below. Ionization energy decreases, electronegativity also decreases, and flame coloration, these two have no color, beryllium, magnesium. This is the brick red, crimson, grey green and crimson color. The element calcium, strontium and beryllium and radium are known as alkaline earth metals, but the term is often applied to the whole group of group 2. All elements are silvery white metals and boiling in their compound is normally described in terms of ionic model. Some aspects of the chemical properties of beryllium are more like those of metalloid with a degree of covalence in its bonding. The elements are denser, harder and less reactive than the group 1, but still more reactive than many typical metals. Lighter elements, beryllium, magnesium, form a number of complexes and organometallic compounds. Comparative study of and diagonal relationship in the groups. Diagonal relationships. In periodic table, it is observed the first element of group 1. First element of group 1 like this, lithium. So similar with the second element in the next higher group like magnesium is called diagonal relationship. Group 1 and second element of group 2. Group 1, second element of group 2. See, it some about similar size, very much similar size, and properties also similar. The diagonal relationship due to similar polarization powers of lithium magnesium ion despite occurrence of different charges on these ions relation the element with their electronegativity. The diagonal relationship arises because of effects of both size and charge. On descending a group, the atom and ions increase in size. On moving from left to right in the periodic table, the size decreases. Thus, the moving diagonally, the size remain nearly the same. For example, lithium is smaller than sodium. Magnesium is also smaller than sodium. Hence, lithium and magnesium are similar in size. The size of lithium is 0.76 angstrom and magnesium is also 0.72 angstrom are close. So, in situation where the size is important for their behavior to be similar. Silent features of S-block elements. Properties of alkaline elements. Lithium is the smallest element in the group, has highest ionization energy, melting point, heat, atomization. It also has lowest density, any solid at room temperature. All alkaline metals have characteristic flame colorations due to radial excitation of the outermost electron. And this is the basis of their analytical. The alkaline metal reactive with water. Alkaline metal with water give metal hydroxide and hydrogen gas liberated. Their reaction trend to water as follows. Lithium react with water gently, sodium vigorously with ignite potassium, explosive. Rubidium and cesium are react explosively. Hydrides. Group 1 element react with hydrogen to form ionic hydrides. With the rock salt and the ion present in the hydride H-, the hydrides react violently with water. This sodium hydride with water gives sodium hydroxide and hydrogen gas liberated. Finely divided sodium hydroxide can ignite if it left exposed to humid air. Such fire is difficult to extinguish because every carbon dioxide is reduced when it comes in contact with hard metal hydroxide. Hydrides are useful as non-nucleophilic bases and reductor. This reaction with ammonia, this and hydrogen is liberated. The sodium nitride. Solubility of hydration. All the common salt in a group element 1 are soluble in water. Solubility cover a wide range of values, some of the most important being those of which there are a greatest difference between radii and cation and anion. Thus, solubility of lithium halide increase for fluoride to the bromide, whereas cesium tends to reversed. Here, sodium ion, potassium ion, magnesium ion and calcium ion compound in a group 2 elements are generally much less soluble in water than those group 1 element, even through the hydration enthalpy are more negative. These are the hydrogen enthalpy. With the exception of the fluoride, the salt is slightly charged ions are usually soluble in water, and those doubly charged anions, such as oxides, are usually only sparingly soluble. These tend insolubility hydrolysis can also be explained in hard and soft acid-base terms. As the group is descending, the ions become less hard. The fluoride and the hydroxide, small hard ion, are insoluble for harder beryllium, magnesium, but more soluble for beryllium. Beryllium is most strongly hydrated by hard oxygen in H2O, and relatively soft beryllium much more weaker. The atmospheric nature of beryllium leading to the formation of beryllium hydroxide under a strong basic condition means that elements forms an extensively series of berylliate that build in beryllium oxide tetrahedral. H2O molecule directly coordinated beryllium is very strongly held in aqueous solution, exchanging only very slow with free water. The hydrated beryllium cation, beryllium hydroxide, act as acid in water. Here you see with acid give hydronium ion. It gives acid. Okay. Here we start halides. Halides are reaction with halogens, like group 1 element halide MX. By directly combination of the element, most the halides have 6,6 coordinate rock salt structure, but cesium chloride and iodide have 8,8 coordinate cesium chloride structure. The enthalpy of the formation of all halides are large negative, becoming less negative from the fluoride ions for each element. Enthalpy of the formation become less negative for the fluorides on descending the group, but become more negative for the chloride, bromide and iodide. These trends can be rationalized by considering Born-Haber cycle for formation of halide from the elements. These calculations treated bonding in alkaline metal compounds as purely ionic. However, the heavier metal ion, there is increasing contribution from covalence as the ion become larger, more polarizable and less harder. These calculations treat the bonding of alkaline metal compounds as purely ionic. However, for the heavier metal ions, there is increase in contribution for covalent. As we saw in the requirement that sum of enthalpy changes round a Born-Haber cycle to be 0 implies that enthalpy of formation of the compound. The lattice energy cannot be calculated directly. It is evaluated by using a series cyclic operations, that is lattice energy of NaCl can be calculated by using the following Born-Herb cycle. See, this is the Born-Herb cycle. Born-Herb, the scientist, they suggest the calculation of lattice energy or heat of formation. See, HF is heat of formation of NaCl, U is the lattice energy, H ionization potential of sodium. See, this is the sodium ionization potential. This electron affinity of chlorine, it is electron affinity of chlorine. This is the electron affinity in this sodium and chlorine in gas form. See, first they ionize and they form ionization energy and electron affinity. Here H sub is the sublimation of sodium. Sodium sublimizes gas to solid, and this is the dissociation energy, chlorine. This solid to gas and half chlorine is formed, it is the dissociation energy, and this solid and gas when react, it is heat of formation, and when both gas ions react, it is lattice energy. Where the cycle was completed would result the zero energy change. See how. Lattice energy, this ionization, affinity and dissociation, sublimation and heat of formation, if all calculated, it gives zero energy change. From the above equation, lattice energy of NaCl can be determined experimentally. Born-Haber cycle also used to determine electron affinity, which cannot be determined directly for endothermic reactions. For various salts, that lattice energy determined experimentally with the calculated value of Born-Haber cycle given below. This is the experimental data of calculation of lattice energy, and this is the calculated data of the salt of lattice energy. See, lithium chloride, when lithium chloride we consider, this is to the experimental value and this is to the calculated value. Like NaCl, we also find some about close value of experimental and calculated value, as here we see. Properties of hydrogen. Why we discussing hydrogen in this group? Because at top you see hydrogen 1s1 is the configuration of this element. Because this configuration, it at the top we see group having a top of hydrogen. Hydrogen having different properties as usual, the NS1 block elements. Thus, hydrogen not studied into any particular group in the periodic table because it is a unique element in many ways and deserve separate concern. In general, the element except hydrogen in group 1, they form closely related group and probably have at least complicated chemistry other than other group. physical and chemical properties of element are very closely related to the electronic configuration and size. Elements are all metal, excellent condition of electricity, typically soft, highly reactive. They also lose held one valence electron, form univalent ionic and colorless compounds. Their hydroxide and oxides are very strong bases, and oxo salt are very stable. Hydrogen is most abundant element in the universe and is also common in Earth, being the third most abundant element after oxygen and silicon on the surface of the globe. The gradually recognition of hydrogen as an element during the 16th and 17th century forms part of the obscure and tangled web for the experiment that were carried out as chemistry emerged from alchemy by become a modern science. Despite it is very simple electronic configuration, hydrogen can paradoxically exist over 50 different forms, most of the which being well characterized. This multiplicity of the form arise firstly from existence of atomic molecular ionized species in the gas phase. Hydrogen H, S2, H plus, H minus, S2 plus, S3 plus, H11 plus, secondly, from the existence of three isotopes H1H1, 1S2, 1S3 are corresponding D, D2, HD, DT, deuterium, tritium, deuterium, tritium. Hydrogen is colorless, tasteless, odorless gas which has only slow solubility in liquid solvents. It is comparatively unreactive at room temperature. Through it combined with fluoride even in the dark and readily reduce aqueous solution of palladium chloride. This reaction can be used a sensitive test for the presence of hydrogen. Palladium chloride and hydrogen, it form SA. As at higher temperature, hydrogen react vigorously, even explosively, which may metal and non-metal to give the corresponding hydride. Activation means homogeneous hydrogenation catalyst. Industrial importance, the process include hydrogenation of many organic compound and use cobalt compound as catalyst in the hydroformylation of olefins to aldehydes and alcohols at high temperature and pressure. After all this, you check your progress. Here are some questions which can you see. In group 1, the value of the first ionization energy order among lithium, sodium, potassium. First ionization energy, ion forms. You see, first ionization energy of lithium is the highest and least with potassium. This is the answer of the first question. In group 1, value of the metallic radii in the order among sodium, potassium and rubidium. rubidium is the highest, and sodium metallic radii सबसे छोटा means lowest radii is sodium. And in group 1, which ion liberate most extensive energy of hydration? In this you find sodium. And for further query and for learning, you go through the JDLE. For further studies, you go through with these suggested studies like JDLE, Concise Inorganic Chemistry, Inorganic Chemistry, Gray, Massey of Pearson publication, Principle of Inorganic Chemistry, Puri Sharma Kalia and others, and Inorganic Chemistry, P.A. Koch. If you have any query and you want to learn more, you mail me in this number and contact in this. Thank you.